Assalamualaikum and good day everyone. We will continue our topic for this statistical analysis using SAS with association and prediction. So first make sure that your previous example exercise you save it as whatever name that you easily to find it later, okay, in the dedicated folder that we created when we start uh, discussing this statistical analysis. And if you want to follow me, I put numbers for ANOVA association as example, so that later I know which file that I can take a look the examples to perform the same analysis. Okay, right, for this topic part 5, so you can actually create a new SAS program. Okay, and we will discuss about association and prediction. So for this particular examples, we want to start with the scatter plot where we check graphically what are the relationship between two quantitative variables or numeric variables. And based on this example, we take a look at the weight and oxy from the data fitness. And the procedure that you can use to generate this chart is proc sg plot or proc sg scatter. So this is what are the proc that you can use to generate the scatter plot. Okay, so for the purpose of example, I use proc sg scatter to show you what are the output. Okay, make sure that this is a new program, proc sg scatter data equals to fitness. Okay, plot, what are the two variables that you want to plot against. Okay, for this is oxy A against weight. Okay, I have some typo in my examples. Okay, if you copy and paste my code, be careful. Right, okay, and then I run. Okay, so this is example of the scatter plot. And to make it more easily to read, you can actually put the title here. Okay, title scatter plot for example Aussie A and weight. Okay, don't forget the semicolon and cancel out the title. Okay, because we have a lot more reporting that we want to do further in our program file, so that's why always put the title here to reset the title for each of the step. Okay, so now it is more readable compared to previous one since that they have a title. Okay, right, next is what if you have more than one instead of just oxy A and weight. Okay, so what you can do is you can use, instead of plot, you use the same proc sg scatter, but now the statement is compare. Okay, compare, your y is oxy A, your predictor is should be you can include h, weight, and r time A as example here. Okay, and then you can run. So you have three separate scatter plot here. H oxy A versus H, oxy A versus weight, and oxy A versus R time A in a single plot. Okay, but this is not related to each other. Okay, or you can do more by uh, I use another proc SG scatter procedure. Proc SG scatter data fitness. We use matrix, okay, to produce a scatter plot matrix, which is sometimes more informative compared to only just uh, only just scatter plot. Okay, and then you can run, and this, okay, I'm missing histogram. Okay, alright. Okay, so you can take a look, a glimpse of your data, what are the relationship, and since that we will show you multiple linear regression model. So the most important characteristic that you have to investigate is the linearity, okay, and the normality lah, of course. But uh, uh, remember that our data is not only a small data set, n equals to data uh, n equals to 10. Okay, so this is not quite you have to increase the sample size to get more relevant results. Okay, right. So that for the purpose of this, I only show you examples. Okay, so you can use later, you can use different data set to take a look what this particular procedure will give you based on your uh, own data set, right? So when you take a look at this, let's say that we take a look at uh, oxy A and maybe R time A. Okay, so here you can see a negative linear correlation. So means as the value of R time A increase, oxy A tends to decrease. Okay, since that because your oxy A is your Y, so that's why if R time A increase, oxy A tend to decrease. Okay, they inverse inverse effects. Okay, maybe you can take a look at the weight. Let's take a look at the weight. It's not too okay. Maybe just when we take a look at the weight, you can see a slight this one lah. Okay, even though that there is some outlier here because this is a uh, small data, but in general we can say it exhibit a positive linear correlation. But still we cannot for sure give the degree of how this particular variables have correlate with each other. Okay, the degree, the strength is cannot be measured unless you perform the next procedure, which is correlation. Okay, so after you do the plots, okay, what you can do is you take a look at the correlation. Okay, so based on my example, I show you two different correlation. Depends on whether you use parametric or non-parametric. If non-parametric, you have Spearman rank correlation. If parametric, you have Pearson correlation. Okay, the difference is you for Spearman, you have to put the Spearman in the prop core line. In prop core line, you put the Spearman. Okay, right. And let's take a look at the output. So for the purpose of example, I just show you the Pearson correlation. Okay, prop core data equals to fitness, okay, var age, weight, r time. Okay, this is your predictor, and your y, your response variable is oxy A, and then you run. Okay, let's take a look at the examples. Okay, so this is the thing that you need to take a look at when you perform the correlation. Okay, so this is actually the probability, the significant value of the correlation coefficient. So means that any value that greater than 0.05, it means that you cannot explain the relationship because the relationship is not significant. So based on this, we can take a look at only r time A have a significant relationship, since that the p value is less than 0.05, and you can use this value negative 0.9 to explain the degree of the relationship between oxy A and r time A. Okay, so this is strong negative linear correlation between oxy A and r time A. Strong negative, because this is negative and 0.9, strong negative. Okay, right, so that is based on examples. You can take a look on later more on this based on your own data set, how correlation will produce this value, okay, depending on your data, right? And for this topic, okay, we will discuss simple linear regression. Okay, so for simple linear regression, we will use another procedure, which is prop-reg. Okay, I will show you univariate first, which is only one variable. Okay, and you use prop-reg, one variable based on data fitness. Okay, the variable that I want to investigate is model, okay, r time A equals to oxy A. Okay, I put the x first. Okay, sorry, you should put the y first. You should put the y first. So if let's say this is y is oxy A here, I should put oxy A r time A. Okay, just use this example, even though that my notes is some sort of much like the predictor and response is not the same as this scatter. I make a correction here. Okay, output out, reg out, r e p equals to y hat, right? Quick. Okay, I run this one. Okay, so based on this, the thing that you need to take a look first is the f uh, f test p value, to take a look whether the model is good fit or not. Since that the p value is 0.05, it is a good fit. It means that the predictor can explain the response variables. And okay, now our x is r time A. If you do the same as my example in notes, instead of r time A, your variable will be oxy A. Okay, so that will differentiate. So depends on which variables that you specify as the predictor and the response, you will have different output. Okay, and the thing that you can also take a look is the R square and adjusted R square. But if you only have one particular models, this particular value is you cannot compare with the with another models. Okay, so the value, if it is a stand-alone value, it doesn't means much. But 0.8 is quite high. It means that 80% of your predictor explain your y. Okay, it's quite high. Okay, that's the thing that you can actually use to explain, and you can also use this adjusted R square for if you have models, you can compare whether which models have higher R square or adjusted R square. Okay, for adjusted R square, it is good for multiple linear regression, since that it consider how many variables that you include in the models. Okay. Okay, so this is the output that they will give you, the plots and so on. All right. Okay, so that's about univariate models, and this is for controlling diagnostic plot. So if you don't want any plots, you can put plots none. This is and so on and so on. For this particular example, you can try it on your own, how your output will be if you use this a particular specification in your proc-rec procedure. Okay, and for making prediction, the thing that we will do is, okay, first, for this data prediction, we will create a new data named prediction, where this is the value we want to predict if our uh, our x is what value. Okay, so for these cases, since that they use the oxy a as the x variables, so that's why the data prediction should be the oxy a lah, in the oxy a variables. Okay, all right, so to make sure that I use the same template as this, okay, I need to do some adjustment first. So I just use the same lah. Okay, even though that is not okay. R time a, see, this is for oxy a. Okay, or else I have to change the prediction value. Okay, so this is my new generated regression models. Okay, and first the step is to do the data prediction, data setup. Okay, I just run this one, data prediction, this one, I run. Okay, and then the next thing that I do is I combine the data. Okay, data combine. Okay, data combine. Okay, set fitness, the first data set, and the second one is prediction. Okay, run. Okay, so when you take a look at the output data, okay, now my oxy A will have extra observation. Okay, this extra observation is the data prediction that we specify previously, and we will use this as the value to predict the R time. Okay, the R time A here. Okay, so what thing that we do next is actually we use the proc-rec. data combine model r time a equals to oxy a slash p okay. So you run this one, and now you will have this predicted value. Okay, so this is how you're making prediction by using simple linear regression in SAS programming. Alright, okay, so I think I will stop here this video. We will continue the discussion later. Thank you for listening. Bye.